probably does.
All right. Oh, yeah. Okay, I'll start quickly because I'm already quite late. After the display port and actually also the Thunderbolt board failed to actually get picture on this thing. We're back to VGA, which always works. Yay! All right. My name is Christian. I work for Red Hat in the desktop hardware enablement group. How do I get the next slide? Yeah, what is the Thunderbolt anyway? I'm going to be really fast now. It's, according to Intel, the USB-C that does it all, which is already very confusing because I said Thunderbolt and now I said USB-C. And I think that's probably going to happen the next 5 years for a lot of people, especially sysadmins and stuff, because it's actually the same port. This newish port is also a Nintendo Switch and everything. And it can be a USB-C, plain USB-C port, but it can also be a Thunderbolt port. And normally you can distinguish them if there's a little error next to it, a little flash. Yes, Hans?
What is a plain USB-C port?
Like there are ports out there, laptops out there that have only a USB-C port that don't have a Thunderbolt port.
2 or 1?
Aye.
Or a 3.1 Gen 1 or 3.1 Gen 2?
I don't know.
Only host or only device?
Exactly.
Does it do USB power delivery?
Exactly. You can distinguish them by the little icon that is next to them if there's space for all the icons. Anyway, so if it's an actual Thunderbolt 3 port, you will have a little bolt next to it. And if it's a Thunderbolt 3 port, it's very fast. It can do up to 40 gigabits per second. It can support up to 4 PCI Express lanes. Sometimes, not on all chips. This is also up to, so it's also up to 8 DisplayPort lanes, and it always supports USB 3.1 if it's a Thunderbolt 3 device. And you can daisy change up to 6 devices, and then it's done. It supports charging your laptop, and the devices can use up to 15 watts. And there are people, the most use case I think for now, which the hardware is mostly available for, is docks, like this guy here. It's a Thunderbolt 3 docks for Lenovo. But there's also, for example, from Razer, an external enclosure where you can have a GeForce graphics card for all your Ethereum mining. How do I do the next thing? Yeah. So the confusing part about the connection modes is that the one port can be actually 4 ports. It can be in USB only mode, which if you connect a USB plug, a USB device in it, the Thunderbolt port actually switches into USB only mode and it acts as a normal USB port. If you plug in the DisplayPort device, then it can be also just a DisplayPort. And it can also be a combination of DisplayPort and USB. And only if you have the right cable, the cable also needs to have a little flash thingy on it, like this, only if you have the right Thunderbolt, USB-C cable, whatever you call it, then you get actually the Thunderbolt controller into its native Thunderbolt mode, where you get the high speed and the full, the PCI Express bridges to the device. And you get all the super nice features and, including, of course, because it's PCI Express, DMA, which means that someone can just read your memory or write into your memory, whatever, right? And it took Intel apparently 3 revisions to realize this problem, or the CIA leaks or something. So in Thunderbolt 3, we actually have security modes. And the security modes are, there's 4 of them, and you can set them in the BIOS in most computers. Not all 4 might be supported. I think Lenovo started not enabling the none mode anymore, because none mode is basically legacy mode, which means that you don't get any security. And then you have DisplayPort only, which only gets a DisplayPort if it actually is working. And then there's 2 secure modes, which means the user mode and the secure mode. And in both of these modes, in user space, we actually have to tell the device to work. We have to you plug the device in, the device registers within the kernel, but we have to say okay, we want this device to be activating, and only then we get the PCI Express lanes, and only then we get the malicious attacks. Hopefully not, but maybe. And the difference between the user mode and the secure mode is that in the secure mode you can also supply a key to the device, which then you can later use to re-identify the device. So if someone fiddles with your dock and installs something in there, So then, hopefully this is get caught by the secure mode, or replaces your dock, with a different one. And on Windows, the land of dialogues, when you actually plug in a new Thunderbolt device, you get a bunch of dialogues, like, okay, there's a new Thunderbolt device, what do you want to do with it? Do you want to connect it? Don't you want to connect it? And our designers, the GNOME designers thought that this was a very, very bad idea, because what most of the time happens, people just click on it because it will make your beamer work, or it will make you whatever. And the presenter is already in a hurry because nothing works. And then of course you click everything. You click OK, OK, OK. Anyway, so how do we do this in Linux land? We have the kernel, which gained Thunderbolt support, or Thunderbolt 3 support in 4.13. It exposes the devices via sysfs and UDEF. There's a small system daemon which gets activated by UDEF rules. And then we have the GNOME shell and the GNOME control center talking to it. It's a dbus API, so other people can talk to it too. I'm not sure if it actually happened yet. And there's a command line tool if you want to actually fiddle around with the nitty-gritty stuff, which I don't expect most people to actually want to do. How much time is left? Can I slow down? No, I have to be fast up. Okay, this is the kernel interface, not so interesting, because, normally you shouldn't actually use it. But, just of interest, if you plug a device in, it will show up under sys Thunderbolt. And there's one file called authorized. If you just put a 1 in there, the device will work. It will connect the PCI Express lanes and everything. And then for the secure mode, this is how you would on the command line do it. You create a key, you write it into the device. The key will actually get stored in the non-volatile RAM on the device. And then with the 1, you actually authorize the device and store the key in the device. And then on the next connect, you supply the key, and only then if the device responds with the right challenge to the key, the device will be activated by the kernel. Just a very quick intermezzo. There's also firmware for the Thunderbolt host controllers and also for the devices. So I have a Dell dock to test in Munich. And also there, the cable actually has its own firmware, so you can update your cable firmware. And this works all, this is all done. There's a plugin for the Linux firmware vendor service and for FWRD, and it will, you can magically via GUI update your cable. So the little daemon that I wrote in the last few months is just exposing the sysfs, where it's a very small daemon actually, via dbus API, and the main use of this daemon is basically for the GNOME shell to, thank you, to speak to it, or for other clients to speak to it. You can use it to authorize and enroll the device from user space. It uses Polkit, and once a device initially was enrolled, it has a little database, it's just files in the file system to remember them, and then on the next time you plug the device in, it will just automatically, even before the GNOME shell is loaded or something, will automatically authorize the device, if you said it should do that. Exactly, so the dbus API is also very simple, so it has only, you can get the devices, you can enroll a device, you can forget the device anymore. And there's one little thing there which is called the Fortify mode. So normally, this is not so super, I skipped this. There's also the command line, which does the same thing, authorize devices, enroll devices, list devices, modify for changes. But the way we normally think what users going to do with it is that it just magically works. So if you are logged in and your session is unlocked and you plug a device in and you are also the admin, like you are in the wheel group, then we will basically ask PolicyKit, but there's a special policy code that will check that you are, if you're an admin. And if you are an admin, it will just automatically authorize the device. And if not, you will get the usual PolicyKit dialog, like wanting to enter your password. And if you have the admin password, you can go and also will authorize the device. And then remember it for the future. If you're not logged in, or the session is locked, then we don't do anything, because it might be someone else trying to steal your main memory, and by just plugging a device in. And what we do is we throw up a dialog, basically, like this, where you say, there's a new Thunderbolt device that has been attached to your computer, and what you need to do is to basically replug the device. So there's not even, like in the GUI, there's no way to actually afterwards authorize the device via click or something. What you need to do is physically take the cable, unplug and replug it while the session is unlocked, which is what our designers came up with, the best solution to not, have another dialog that says authorize the device. Yep, there's also a little user, like a little snake thingy icon when something's actually happened in the Thunderbolt bus, because for the Dell dock, for example, it takes up to 10 seconds from you plugging the device in until your network card in the dock is actually working, because network manager has to do its magic, and the cable has to first be authorized, and after the cable is authorized, the dock has to be authorized, and this this takes forever. Yeah.
How do they do the authorization? So what cryptographic algorithms are used?
So the authorization, you mean if you're in secure mode?
For example, to exit those, you can give it a key, right?
Yes, you give it a key. Yeah.
How does it work?
So you give it a key, and then it's basically like hash something. You have the key in the device stored, and you challenge the device with some random data, and it sends you like some HMAC, whatever thing back, and the kernel does the same thing and compares the hashes. And if they match, it's the same device.
Okay, they use HMAC.
Yeah. There you go. And then there's also a little control center thing, which basically allows you to manage the devices. So, where you can remove the device again once you've done it. And it will also help you, like if you're plugged in a device while the screen was locked, you will also, find a more descriptive, hopefully, message there. Like when you click on the little notification thing, you can go there and it will tell you that you have to reconnect the device. Yeah, and that's it. Yeah, made it. There's not much time for questions, but I think, yeah.
Very short one.
Very short.
If you want to share a Thunderbolt device between multiple computers, so each of them has its own key. Is this?
They have more. The non-volatile RAM has support for more than one key. Yeah, but I think I haven't tried it. I used like 4 or 5 computers and it still worked. But I guess at some point it will overwrite the keys, but 3 or 4 at least work.